In this segment, we're going to continue multiplying fractions, except this time we're going to talk about multiplying with mixed fractions. I'll also show the connection between multiplying by a mixed fraction and multiplying by an improper fraction and how the two are related and why multiplying by an improper fraction is sometimes the easier or faster way of going. Again, I want to review the critical understandings that are necessary. Multiplying any number by 1 doesn't change the number that we start with. Multiplying by a number less than 1 is what we did last segment, talking about multiplying by proper fractions, will always produce an answer that's less than the starting number. And in this section, we're going to be talking about multiplying by mixed fractions, and by definition, those numbers are going to be greater than 1. So our answers are going to be producing something that are greater than what we started with. And again, I cannot stress enough that this is an important idea that students need to constantly be reminded of, so that the diagrams make sense to them and that the numbers make sense. Because if not, it's very confusing. The first question we're going to work with is 1/4 times 1 1/2. So my starting number is 1/4. I'm multiplying by 1 1/2. 1 1/2 is bigger than 1, so I need to expect my answer to be bigger than 1/4. So I start off making my question. I need 1 whole, so there's 1 whole, and a half. So I take my ones, and I take another one and I cut it into 2 pieces so I can make my half. And I want to shade in all of the 1 1/2, so I'm going to shade in the 1 1/2. And there it is, shaded in 1 1/2. Now on the other side, I want to divide it into quarters. But before I do that, I'm just thinking, well, no, I'm going to divide it into quarters. Let's do that right now. Divide it into quarters. I need one of those quarters shaded in. So now I've shaded in 1/4. Here's my 1/4 in the horizontal position, and here's the 1/4 on the other side as well in the horizontal position, and I'm looking for the double shaded regions as usual. However, I notice that my double shaded regions aren't the same size. This isn't the same size as this, and this is what I was alluding to a little earlier when I said I was going to change things. Well, I'm talking about 1 1/2, so maybe I should talk about 1/2 regions. So I'm going to rearrange and put in an extra half here so that I'm talking about half regions. So I haven't really changed my diagram too much. I've just changed it from 1 whole to 2 halves. So now if I take a look at my question, I've got how many halves? I've got 1 yellow half, 2 yellow halves, 3 yellow halves. And so this is where my 1 1/2 could be rewritten as 3/2. There's my improper fraction version of this. And so if I'm using the technique of multiplying my mixed fraction by changing my mixed fraction into an improper fraction, I've got 1 1/2 is now becoming 3 halves. And now when I go to multiply it, 1 times 3 is 3, and 4 times 2 is 8. So I should get the answer of 3/8. And let's see how we get that. Well, I've got 1, 2, 3 double shaded regions. So that's where I get my 3 on the top. And then how do I get eighths? Well, I've divided any 1 into 8 sections. If we continue and draw our lines across into our quarters now, we can see we've got 1, 2, 3, 4, 5, 6, 7, 8. And I don't have to count all of the sections because I'm looking at parts of a whole. And here is 1 whole, and I've divided this up into 8 sections. So I can do the same thing over here if I wanted to, but it's kind of redundant. I'm still going to have 1, 2, 3, 4, 5, 6, 7, 8. So I'm still talking about eighths. So I'm going to have 3 eighths. And I could take this shaded region here and bring it down into this area here so that I'm counting just on 1 whole piece, in which case I would still have 1, 2, 3 out of my 8 pieces. So my answer is going to be 3/8. So we've shown that it works in either the mixed fraction form or in the improper fraction form. But once we have it in the mixed fraction, we have to have extra boxes. When I go to do my next question, where I'm going to have a mix times a mixed fraction, we'll see that leaving it in its mixed form is somewhat problematic, and it's a little easier to change it into its improper form. So in this question, 1 1/2 times 1 1/3, I start with 1 1/2. I'm multiplying by a number bigger than 1, so I need to expect an answer bigger than 1 1/2. So here's my diagram starting to be built. I have 1 1/2, so I have 1 and 1 and 1/2 times 1 and 1/3. So I like my second number on the top. So there's 1 and 1/3, because this is made up of 3 pieces. So 1 and 1/3 across the top. And now for something a little different. Down the side here, we need more than 1. So we need to go 1 and 1/2. So I need to extend my diagram down. And I'm sorry it just comes off the bottom of my screen, but it's not going to be too problematic, I don't think. So now, since I extended my diagram down, I have to extend my fill down for my 1 and 1/3, so I'll do that first. So now looking across the top, from left to right, I filled in 1 and 1/3 of my distance all the way across. And since I've got 4 boxes, I had to fill it all the way down. But I'm really just looking left to right now. So left to right, no matter where I am in my picture, I've got 1 and 1/3. Now it's time to work top down. So I need to fill in 1 hole and halfway down. So I'll show that next. So here I'm showing my 1 hole. I've got 1 hole going down all the way across, and I'm filling that all the way because I'm talking about going down, so I'm filling it all the way to the right. So far in both of these boxes from here down, I filled up 1 hole all the way down. Now I have to fill up 1/2 all the way down. And so here's my blue half for this, and here's my blue half for this. So going across in yellow, I filled 1 hole and a 1/3, and going down, I filled 1 hole and a half. So there's my 1.5 times 1 1/3, and now I'm looking for double shaded regions again. So what I've done now, I've just completed my diagram. We had it initially going across in 1 and 1/3, so I cut my hole into 1/3 going down. I also have horizontally are talking about halves, so I cut each one in halves going across. So altogether then, in any segment, I have 6 pieces, and that makes sense because I have halves and thirds. 1/2 times 1/3, it would give me 6 sections. So I've cut it all 4 large squares into 6 sections. And what do I end up having when I put all of this together? There's a couple ways of saying it. I have 1 whole square that's double shaded, so there's my 1. I have 1/3 of my section. 1/3 of 1, 2, 3 is shaded in. Here's 1/2 is double shaded, and this piece down here is 1/6 double shaded. So I have all 4 pieces now that I have to put together. So our work might look something like this. 1 plus 1/3 plus 1/2 plus 1/6. I can't add these together because they're not the same size pieces, but I can convert them to the same size pieces, and my diagram helps me do that. I could rewrite them this way. Instead of saying 1 whole, I have 6/6. Instead of saying I have 1/3, I have 2 out of the 6 that are double shaded. Instead of saying 1/2, I have 3 of the 6 double shaded, and I still have my 1/6. So now I have common denominators that I can add up together and see what I get. Adding that all up, 6/6 plus 2/6 plus 3/6 plus 1/6 gives me a total of 8. 11 and 1 is 12/6. 12/6 is equal to 2 wholes. And I can show that by taking my diagram and taking this piece here and sliding it down to here, this piece here and sliding it down to here, and this piece here and moving it down to here, and therefore I'd have 1 whole and 2 whole double shaded pieces for my answer of 2. Over here on the right, if we change it to our improper fractions, 1 and 1/2 is changed to 3/2. 1 and 1/3 is equal to 4/3. And we can see my 3/2 is talking about my 1, 2, 3 halves that are in blue. And my 4/3 is talking about my 1, 2, 3, 4/3 that are in yellow. So I multiply those together and I get a total of 12/6, which again gives us our answer of 2 wholes. So we can see how our diagram works with our mixed fractions, and it also works for our improper fractions. Continuing with the idea around cancelling, if I change my numbers instead of 3 times 4 to 4 times 3, because it means the same thing, I can now get a question that looks like this: 4/2 times 3/3. 3/3 is one of my magic ones, so that's a 1, so that's where we show that counter-canceling when we do our canceling. So again, we want to make sure that we show our students where these numbers come from. But 4 over 2 can be renamed as well to this. So 4 over 2 can be written as 2 over 2 over times 2 over 2 times 2 over 1. 2 times 2 is 4, and 2 times 1 is 2. And here's another magic 1 right there. So 2 over 2 is a 1, so 2 goes in there once, 2 goes over twice. So now I've got 2 over 1. This 2 over 1 is this 2 over 1 right here. And so students can see where the numbers come from, and what I'm left with is an answer of just 1 times 2 is 2 and 1 times 1 is 1, giving me just the answer of 2. If we wanted to use this and reduce it, we could say that 12 divided by 6 is 2, but we could also say, what's my magic 1? I could divide by a magic 1 of 6 over 6 to give me 2 over 1. And where does this 6 come from? Well, I've done a magic 1 of 3 over 3, and a magic 1 of 2 over 2, and 3 times 2 is 6. And so 2 sets of magic 1s, one 3 over 3 and one 2 over 2, could end up giving me a magic 1 of 6 over 6. So I can show lots of these connections, and they have to be made explicit to our students. Now, drawing it out with all the boxes and the squares and the shading can be confusing and problematic to draw, so here's a slightly simpler form of doing it. It's a nice intermediate step to go from those shaded boxes to the symbolic. So now we've got an area here that's 1 by 1, so I'm just going to fill it in what my answer would be. 1 times 1 is 1. This section here is 1 high by 1/3, so it's going to have an area of 1/3. This piece down here has got a length of 1 by a height of 1/2, so its area is going to be 1 times 1/2, which is 1/2. And this corner piece down here has got a height of 1/2 and a length of 1/3, so 1/2 times 1/3 is 1/6. And you can see we end up with the same size pieces and the same numbers we had in the other diagram. And it's important for the students to understand that this one down here is one that tells us what our common denominator has to be, because we have both the halves and the thirds all in the same piece. So we change everything to sixths. And so everything's in 6. So we have 6 6 plus 2 6 plus 3 6 plus 1 6. So 6 plus 2 is 8. Plus 3 is 11, plus 1 is 12, and we get our 12/6 again. So this is a nice intermediate diagram, not quite so cumbersome and faster to do. And down here is really where all the action's taking place anyway. So if you want, you can spend some time drawing the 1/2 times the 1/3 diagram to get the 1/6 and talk about how these other diagrams would work together. And again, since I'm multiplying by a number bigger than 1, I expect an answer bigger than 1 1/2, and I do. I get an answer of 2, so that makes sense. And so we've talked about how to show multiplication of a proper fraction times a mixed, and a mixed times a mixed, and talked about what should I expect for my answer, what size should my answer be.